All right, so today we're solving the unit test for limits and continuity under the calculus course. Let's go. Neil's teacher gave him a flowchart below and asked him to find the limit of fx as x tends to 0 for fx. Okay, this. So we know the table. Drag the cards below to show Neil's path to finding the limit. So basically, along with this person, we also have to attempt to find the limit, and then only then we would be able to tell what are the path that we should follow. So the first thing is first, we have to plug in x equals to 0. If we do plug in here, anything to the power 0 is 1, and 2 minus 1 is 1, but ln 1 is 0. So we tried direct substitution here, but we failed miserably because anything ln 0 is just ln 1 is just 0, so ln of 1 is 0. So anything divided by 0, like it is not, it is just indeterminate. No, yeah, 0, but at the same time the numerator e to the power 0 is also 1, and 1 minus 1 is also 0, so we have indeterminate form, which is d. Okay, and e to the power 0 is 1, 1 minus 1 is also 0. So what do we do now? If we get these, then because it's either of these trig identities, factorizing, or conjugates, what do we have here? 2 minus, okay, so trig identities and then approximation, or approximation. All else fails, graphs and tables can help appropriate limits. So how do we apply factorize? We can't factorize this anymore, and like getting conjugates, we don't have any conjugates as well. So, and this is not a trigonometric equation such that we can apply trigonometric identity. So the next step will be h, which is approximation. Okay, right from here, d, we just go to approximation. That's all right. So find the limit of this as x tends to pi by 2. So we have to draw the graph of sine in order to understand its value. So we know that sine has a graph of like this. So this is 0, this is pi, this is 2 pi, and this is pi by 2. So for pi by 2, you have a value of 1. So again, 1 minus 1 square is just 1, 1 minus 1, which is 0. And for 2 of pi, so pi, 2 times pi by 2 is just pi. And again, sine pi gives us 0, 0 squared would be 0, 0 divided by 0 is the problem. So what we do is we use trigonometric identities to rewrite this, and we know that 1 minus sine squared can be written as cos square x theta. 1 minus sine square I can written as cos square theta, and sine square 2 theta. So we can write sine. We know that we can write sine 2 theta as 2 sine theta, not square. Sorry, sine theta, cos theta, and this thing is squared. So we know that this is 4 sine squared theta cos squared theta upon cos squared theta. Cos squared theta, cos squared theta is cancelled. We have 4 sine squared theta. Now we can plug in pi by 2. So again, the graph of sine. So this is 0, this is pi by 2. We have a value of 1. So 1 squared is 1. 4 times 1 is 4. So our answer is 4 in this case. Okay. So function g and h are graphed. They're asking you to find the limit of gx plus hx plus gx as x tends to -3. So for h, let's go to -3, and we find a value of -3, but we have asked to find the limit. So as we approach this value from negative side to positive side, we get +3 here. So this should be +3 plus g of we have to, okay, -3, we get +2. So 3 plus 2 is 5. So this should be 5. Yep. Which limit, consider the graph of function g, which limit expressions agree with the graph. Okay. Limit of h if x tends to negative 3 is positive 3. Hey, as you can see here, if we go to x equals to negative 3, we have negative 3 and it shows positive 3. It's not true. But if we go to x equals to 3 from the positive side, x equals to 3 from the positive side, from the right side, we have 1. This is correct. And x, as we approach x equals to 3 from the negative side, x equals to negative 3, yeah, x equals to 3 from the negative side, we get a value of negative 3. But here it says it doesn't exist. It's not true. Only this is true. So that is the answer. The function h is defined over the real numbers. This table gives a few values of h. What is a reasonable estimate for function the limit as x tends to negative 6 for function h? So as we approach negative 6 here, left side and from the right side, we can see that the value is approaching negative 1. So we could say safely that the reasonable estimate will be negative 1 because the values are getting closer to negative 1. Okay. Given the function g and asked to estimate limit of g as x tends to 0, three students created which table is accurate, but each table is accurate, but which of the following, which is the best for approximating the limit? Okay, so you want to find limit as x tends to 0. So here the difference between x values are constant. 2. We don't want that. We want it to be decreasing, approaching the value 0, which is done here. And as for this one, hey, we don't have the x value 0. It is approaching x equals to 15, but we to find the limit of x equals to 0. So that's why A is our answer. All right, let g be a continuous function on the closed interval. Well, okay, and what is the best? What is the following is guaranteed by the intermediate value theorem? Okay, we have to carefully analyze this using the graph. So negative 3, it's close. It is continuous. Okay, negative 3 to 3. So no jumps or discontinuity. Where so we have to, let's imagine this is 1 2 3, 1 2 3, negative 3, and this is positive 3. So for negative x equals to negative 3, we have a value of 0. Okay, we have a value of 0 here. But for positive 3, we get 6. For positive 3, 1 2 3 4 5 6, let's say here. So this is the least that it could be. Okay, this is the least. Intermediate value theorem, which is the following is guaranteed. So they're saying that for any value of x, there should be a 5. If this is 6, between negative 3 and 3, it must cross 5, right, for some value because it is continuous. So this is true. And it must cross negative 2. No, this is not true. Negative 2, because it started from 0. So it doesn't necessarily have to go to negative 2. It's not guaranteed. And it's that for at least from 0 to 6. No, if you go to 6, then you're going outside of this range. They have confirmed that it is continuous from negative 3 to 3. So that's why our A is our answer for this one. Function h and f are graphed, and they have asked us to find the limit. First, let's find the limit of hx as x tends to negative 1. So the limit is positive 2. So for negative 1, if you check the value from both sides, it's positive 2. So it's positive 2. For fx, for -1, when we approach, we get 4, even though the value itself is 2, but we only care about approaching it from both sides. It's 4. So 4 to 0 is 8, positive 8. So this is the answer. Okay, find the limit as x approaches negative infinity. We can't plug it negative infinity here directly because it is indeterminable format. So we have to rearrange. And in order to do so, we'll have to you have to divide both sides, the numerator and denominator with x. So this is 3x, so let's divide it with x. And in here we have 16x squared and negative 9x. So we can divide it with root x squared, because x squared and root gets cancelled, so ultimately it's x. So we are preserving equivalence. See, 3x divided by x. Okay, now what we can do is we can take the root common, so we can say the root is common, and 16x squared can be divided by x squared, and here it can be 9x can be divided by x squared, and it's upon we have just 3 because they just cancel out. Okay, so 16x squared and this x squared gets cancelled out, so this ultimately becomes root 16, and we can cancel out 1 here, so it's 9 by x. Okay, and now we can plug in negative infinity here. If we do so, we do have a root. We can't get rid of that yet because there's a minus sign here. So what we can do is it's root 16 minus 9 by, so if it is 9 by negative infinity, the entire thing becomes 0. The entire thing becomes 0 because you're dividing it with so many, yeah, dividing it a large number, so it becomes 0 and effectively nothing. So root 16 is 4, and 3 by 4 is our answer. Oh, negative 3 by 4. Oh, x equals to negative in the denominator. We want to divide both the numerator and denominator by the same quantity in a way that helps to derive the limit. Since the leading term of the coefficient is x, divided by x in the denominator, let's divide with, since for negative values, okay, for negative values, negative, okay, yeah, for negative values, I think the graph will be able to tell us. So it's 3x. 16 is negative 9, negative 9x. So there's that. So for negative, okay, no, I for negative infinity, okay, yeah, because for x, okay, so x and root x squared, this is the key. So as you can see, for negative infinity, they are like this graph and this graph is not same, but the negative of that is the same. So when we consider the negative side, we have to incorporate the negative if you're dealing with x root of x squared, if you're trying to do so. So in that case, a negative sign will be here. So everything is the same except for there will be a minus. So it would be minus 3 by 4. Okay, this is the graph of function g, and select the x values at which x has a removable discontinuity. Removable discontinuity, which is negative 6. We have a negative 6, and removable discontinuity here. We don't have a removable discontinuity because like it's just not continuous. So just negative 6. Consider the graph of function g. The dashed line represent asymptotes, which limit expressions agree with the graph. Limit of gx as x tends to 3, as x tends to positive 3. The limit is, as you can see, is positive infinity. Is correct, but 3 from the negative side. 3 from the negative side is negative infinity, as you can see. So it's not. These are not correct. This is correct because 3 from the 3 from the positive side is positive infinity, and limit of 3 would be infinity if both of those equal infinity. But from the negative 3 from the left side, as you can see, is negative infinity, so only C is correct. Okay, limit as x tends to 1. So just plug in 1 here. So x minus 11, 1 minus 11, and 1 plus 7 is negative 5 by 4. So negative 5 by 4. Okay, the function g is defined over the real numbers except at x equals to 2. Okay, this table gives select values of g. What is the reasonable estimate for function g's limit as x tends to 2 from positive side? So as you approach it from 2 from the positive side, you can see it's getting closer to positive 7. So that's why it would be c7. Okay, function f is defined for all real numbers with a reasonable estimate for x tends to 4. As x tends to 4, it is approaching a value between 6 and 7. So it's 6.7. Even though the function itself has a different value, but limit only cares about what value you're approaching from both sides, and we don't have anything here, so it's just uh, between 6 and 7, and it is closer to 7. That's why it is 6.7 and not 6.1. Okay, g is defined over the real numbers. The table gives a few values. However, is the reasonable estimate for x as x tends to negative 3. So as x tends to negative 3, as you can see here, is approaching value of 5. So we could say 5. Yeah, only from the negative side. Wait, no, the limit doesn't exist because it is only from the negative side, but from the positive side is approaching a value of 1. So they are not equal. So we can't say that the limit exists. All right, so function g is graphed. Select all correct statements about g at x equals to negative 4. So x equals to negative 4. Um, Negative 4, yeah, limits exist both from the negative side and the positive side. It's 1. Okay, so this is true, but yeah, this is also true because the limits exist for both sides. So limit would exist, but it is not defined and neither continuous. So only to a and b will be the solution. It is not defined and continuous. As you can see, there is an open circle, which means there is a removed discontinuity here. Consider graphs A, B, and C. The rationally represents asymptotes. Which graphs agree with the statement? Limit of g as x tends to infinity is minus 2. So as we go to infinity, we can see a value of minus 2. This is correct. And as we go to infinity, minus 2 correct. Here we have minus 1 is not correct. So as x tends to infinity, it's minus 2 here, and it's also minus 2 here. So they're correct. Okay, so let fx be this thing for x is greater than or equals to negative 5, and x is not equals to minus 1, but for x, because for x equals to minus 1, we have a specific value k. So f is continuous for all x is greater than negative 5. What is the value of k? What is the value of k? I.e., what do you get for x equals to negative 1? This is the question. So let's plug in negative 1 here. Because this is for x is greater than or equals to negative 5, but not negative 1. F is continuous for all x is greater than negative 5. So if you plug in negative 1 here, x plus 1, it's negative 1 plus 1, it is 0. It's 0 in the numerator. What about the denominator? Root negative 1 plus 5 minus 2. It's root 4 minus 2, 2 minus 2. So it's just the indefinite form, 0 out of 0. That's why you have to rearrange it and find the value for k. In order to do so, we multiply it with the conjugate of the denominator. So root x plus 5 minus 2 multiplied by root x plus 5 plus 2, root x plus 5 plus 2, and upon we have x plus 1. So a plus b a minus b is over a square minus b square x plus 1 multiplied by root x plus 5 plus 2. And then simplifying further, we have this thing squared, so roots gets out, so x plus 5 minus 2 squared is 4. So 5 minus 4 is 1, we know that, so we can write it x plus 1, and this x plus 1 gets cancelled out with the numerator x root x plus 5 plus 2, so they get cancelled out. We are ultimately left with root x plus 5 plus 2, and now we can find the value of x equals to -1. So -1 plus 5 plus 2, we have positive 4 plus 2, so 2 plus 2 is 4. So you have positive 4 here. There you go. Function f and g and graphed are graphed. They're asking us to find the limit of, first of all, we find the limit of gx because gx is inside as x tends to 2. So as x tends to 2 here, as you can see, the limit for it from the negative side and the positive side are not equal. Therefore, it doesn't exist. Okay, limit of sec. So sec is the opposite of cos. Okay, cosec, sec, cot. So sec is opposite of cos. So it's 1 by cos x. And now we have to draw the graph of cos x. We know it looks like this. This is 0. This is pi by 2. So for pi by 2, we have cos 0. So 1 upon cos 0 is just undefined. So limit doesn't exist. Okay, so for this question. Okay, we have to find the limit of x as x tends to pi from the right side. So this is pi, and we know that x is greater than pi, we have sine x. So we need to find the graph of sine x. We know that this is pi, this is 2 pi, and we are told to find as x tends to pi from the positive side. So if we check from positive side, we get a value of 0. So that's why our answer would be p. Okay. So the correct description of the one-sided limits of h of x equals to -1. So if you plug in -1 here, 2 times -1 upon -1 positive 1 squared, so it's just negative -2, and we have -1 is 0. Okay, so denominator gets 0. Here's the problem. -1 plus 1 is 0. So correct description for one-sided limit at x equals to -1. So what do we do? As x tends to, okay, so in order to solve this, we have a calculator. What we can do is we can plug in the graph. Okay, so here we have a graph, and we want to approach x equals to -1, right? So x equals -1. So x equals to -1. So what do we see? It's positive infinity here. So as x tends to -1 from the negative side, this side is also positive infinity, but from the right side as well is also positive infinity. So both of them should be positive infinity, which is the first thing. Positive, negative, negative, positive, negative, negative, no. Okay.